Alright guys, so now we are going to apply yung natutunan natin sa ating lecture about energy and head regarding the total energy. So we learned from our lecture that the total energy is the sum of the kinetic energy and the potential energy, no? And our potential energy are categorized in two types. So we have what we call the elevation head and we have the pressure head. So on this problem, we are going to apply that. So we have a problem here in which a pipe carrying oil of specific gravity 0.877 changes in size from 150 mm at section 1. So ito yung ating section 1. And 450 mm at section 2. So this is our section 2. So as you can see, the diameter of our pipe has increased from section 1 going to section 2. Well, section 1 is 3.6 meter below section 2. And the pressures are 90 kilopascal and 60 kilopascal respectively. If the discharge is 150 liters per second, determine the head loss and the direction of the flow. So, isulat muna natin yung ating mga given dito sa ating diagram dito, no? So, what is flowing dito sa ating pipe is an oil with a specific gravity of 0.877. So, we have the specific gravity of our oil is equal to 0.877. Huh? So, given natin yan. Now, the size of our pipe changes from 150 mm diameter at section 1. So, the diameter of our pipe dito sa section 1 is equal to 150 mm. No? So, we have 150 mm diameter, okay, of our pipe. While in section 2, we have 450 mm diameter. So, in here, we have 450 millimeter diameter. No? Now, section 1 is 3.6 meters below section 2. Okay, so we're going to write that. So, from here, okay, assuming this is the level of our section 1. So, this level of section 1 is 3.6 meters below section 2. So, that means this distance right here is equal to 3.6 meters. Okay? Now, the pressures are 90 kilopascal and 60 kilopascal respectively. So, therefore, dito sa ating section 1, our pressure is equal to 90 kilopascal. And dito naman sa ating section 2, our pressure is equal to 60 kilopascal. Now, if the discharge is 150 liters per second, so our Q2, which is the discharge, okay, so let me write that here, is equal to 150 liters per second. Okay? So now, we need to determine the head loss. Okay, so yan ang ating required. Let me write that here. So, we need to find out our head loss and the direction of the flow. Okay? So, yan ang mga kailangan nating makuha. So, now let us start our calculation. No? So, we have our solution right here. So, first, we need to understand that what we have here is a pipe. So, therefore, if our discharge is equal to 150 liters per second, so that means ang pumapasok sa atin dito is also 150 liters per second. No? So, if our Q2 is equal to 150 liters per second, so that means our Q1, which is also equal to Q2, is also equal to 150 liters per second. Okay? Now, as you can see, yung mga units natin dito are in pascals, millimeter, meters, no? So, therefore, we need to convert these liters into cubic meters, no? So, our conversion factor is that we have 1,000 liters in 1 cubic meters. Okay, so therefore, our Q is equal to 150 divided by 1,000, which is 0.15 cubic meters per second. Okay, so we have the value of our Q. Okay, so that's very clear now. Now, to review, we learned that the total energy is equal to the kinetic energy and the potential energy, no? So, we already got this equation before sa ating lecture about energy and head. So, I'm just going to write here the equation. So, if you want to learn more about that equation, so you have to watch again our video. So our equation for the total energy is equal to kinetic energy, which is velocity squared over 2g. Then we need to add this to our pressure head, which is pressure over our unit weight. Then plus our elevation head, which is equal to z. Okay? So basically, we know the value of g. This is the acceleration due to gravity. We have the pressures here, no? So we have the inlet pressure and the outlet pressure. We can get the specific weight, and we also got the elevation, which is 3.6 according to this diagram, di ba? So let us get this one by one. Tandaan natin, ang hinahanap natin is yung head loss. So how to get the head loss? The head loss is equal to the energy inlet minus the energy outlet. Okay, so yung pumasok na energy natin, mababawasan yan as it pass on this pipe. So, magkakaroon tayo ng reduction ng ating energy. So, if we subtract those energy, we will be able to get the head loss. So, kailangan makuha natin tong energy in and energy out. So, yung energy in natin, we can write it also as energy at section 1 minus the energy at section 2, no? Para pare-pareho ang ating mga subscript dito. We have section 1 and section 2. So, kunin natin yung E1 and E2, no? Para makuha natin yung total energy. So, this is our formula. So, kailangan makuha muna natin yung E1. So, therefore, we need to get velocity 1 squared over 2g plus pressure 1 over our specific weight plus z1. Okay? So, at point 1, our z is equal to 0. Okay? So, this will serve as our datum here, no? So, our z is equal to 0. Now, we don't know the velocity yet. So, we need to get velocity 1. So, how are we going to get velocity? Well, we know our Q, which is the volumetric flow rate, no? And we know that Q is equal to velocity times area. Okay, so kunin muna natin yung sa section 1. So, Q1 is equal to velocity 1 times area 1. Well, alam natin yung Q natin. We can get the area dahil alam natin yung diameter ng ating pipe. So, therefore, we can get our velocity. So, velocity 1 is equal to Q1 over A1. Okay? So, ano yung value ng ating Q1? We have 0.15 cubic meters per second. Now, our area, we have a circular cross-sectional area with diameter of 150 millimeters. So, we have pi over 4 times diameter squared. So, our diameter is equal to 150 millimeter, diba? So, we have 150 millimeter. But we need to convert this to meters, no? Dahil na cubic meters ang ating numerator. So we have 1,000 millimeter in 1 meter. Okay, then we're going to square this because area is equal to pi over 4 times the diameter squared. So tingnan natin ang ating unit. We have here meter, millimeter which can be cancelled out. So we have square here. So therefore, our unit for denominator will be meter squared. But we have cubic meter here. So cubic meter divided by square meter, mang matitira sa atin dito is meters. Okay, so therefore, ang unit natin will be meters per second. No? So now let us calculate for the value. Okay, ng ating velocity. So we have 0.15 divided by pi. Okay, so 4 is denominator ng ating denominator, no? So therefore we need to multiply this by 4. Okay? And then we're going to divide this dito sa ating 150 divided by 1,000. So we have 150 divided by 1,000, but this is squared, no? So we're going to square this. So our answer here will be 8.49. So therefore, our V1 is equal to 8.49 meters per second. No? Okay, so nakuha na natin yung value ng V1. So now we can substitute that dito sa ating equation. Ano? So our E1 is equal to our V1 squared, which is 8.49 meters per second squared, over 2 times the acceleration due to gravity, which is 9.81 meters per second squared. So we will add this to our P1 over our unit weight. So we have our P1, which is 90 kilopascal. So we have here 90 kilopascal. Then divided by our unit weight. So by the way, our unit weight, as we learned before, is equal to density times the acceleration due to gravity. But our fluid here is an oil, no, with a specific gravity. So therefore, our unit weight is equal to the specific gravity of the oil times the density of water times the acceleration due to gravity. No? So therefore, we need to get the specific gravity of the oil, which is 0.877. So we have 0.877 times the density of water, which is 1,000 kilogram per cubic meters, times the acceleration due to gravity, which is 9.81 meters per second squared. Okay? So our dimension should be consistent, no? So we need to express this kilopascal in meters, seconds, and kilograms. So first we'll convert this to pascal. So we have 1 kilopascal is equal to 1,000 pascal. Then 1 pascal is equal to 1 Newton meter. Okay, so now we have Newton here. So we need to express this in kilogram, meter, and second squared. No? So 1 Newton is equal to 1 kilogram meter per second squared. Okay, so now let us check our units. By the way, our Z is 0, no? So we have plus 0 here. Okay, so let's check our units. Here we have meter squared over second squared. And in denominator, we have meter and second squared. So our second squared will be cancelled out. our meter will be cancelled. So, ang may iwan sa atin dito is meters. Okay? Yan ang may titira sa ating units. How about dito sa ating potential energy dito? No? So, kilopascal will be cancelled out. Pascal will be cancelled out. Newton will be cancelled out. Okay? So, we have kilogram here which can be cancelled out as well. We have second squared which will be cancelled out. And then we have meter and meter here which will be square meter divided by cubic meter. So, ang square meter natin will be cancelled out. Ang may iwan sa atin is meter, no? So, this is denominator dito sa ating denominator, no? So, therefore, it will be a numerator. So, our unit will be in meters. So, meters plus meter, we can add them up, no? So, therefore, we can now proceed calculating our E1. So, our E1 is equal to, para maging madali, unahin natin to, no? Okay, so we have here 8.49 squared divided by 2 and divided by 9.81. So we have here 3.67 meters. Plus, now let us compute for this value. Okay, so we have 90 times 1,000. So we have 9,000 sa ating numerator divided by 0.877 divided by 1,000, then divided by 9.81. Okay, so we have 10.46. Okay, so we have 10.46 meters. So therefore, our E1 is equal to 10.46 plus 3.67. This is equal to 14.13. No? So we have 14.13 meters. Okay, so may value na tayo ng E1. So now let us get the value of E2. So E2 is equal to, so gamitin ulit natin itong formula natin dito, no? So our E2 is equal to velocity 2 squared over 2g plus pressure 2 over our unit weight plus Z2. Okay? So, ang Z2 natin dito is not 0 because it is 3.6 meters above dito sa ating datum, no? So, therefore, our Z2 is equal to 3.6 meters. Okay? So, alam natin yung pressure 2, no? Our pressure 2 is equal to, nandito siya sa ating given, our pressure 2 is equal to 60 kilopascal. So, we have P2 is equal to 60 kilopascal. Okay, so, now, we need to get the value of velocity ng ating section 2, no? So, katulad ng ginawa natin dito, our velocity is equal to the flow rate divided by the area. So, our velocity 2 is equal to Q2 over area 2. So, pareho lang ang ating Q, no? And we have that here. Our Q2 is equal to 0.15 cubic meter per second. So, we have 0.15 cubic meters per second. And our area is equal to pi over 4 diameter squared. So, ang ating diameter is equal to 450 millimeters, no? So, let me put a bracket here. We have 450 millimeters times 1,000 millimeters in 1 meter. Okay, and we're going to square this. So, our velocity 2 is equal to, let us now calculate for that. Okay, so we have 0.15 divided by pi times 4, okay, and divided by 450 times divided by 1000, we're going to square that, is equal to 0.943, okay, meters per second. Okay, so hindi na natin chinek yung conversion dahil nagawa na natin yan dito, no? So we know that our units are correct. Okay, so now we got the value of V2, no? So we can substitute that here so we can get the value of E2. So our E2 is equal to, okay, so the velocity 2 squared, which is 0.943 meters per second squared over 2 over the acceleration due to gravity, which is 9.81 meter per second squared, plus our P2. So our P2 is equal to 60 kilopascal. So we have 60 kilopascal. Okay, so divided by our unit weight. So our unit weight nakuha na natin kanina, no? 0.877 times 1000 times 9.81. So we have 0.877 times 1000 kilogram per cubic meters times 9.81 meter per second squared. Okay, so yung numerator natin tulad kanina, we need to express that in kilogram, meter, and seconds. So 1 kilopascal is equal to 1000 pascal. Then 1 pascal is equal to 1 newton meters. And then 1 newton is equal to 1 kilogram meter per second squared. Okay, and we need to add our z. So our z is equal to 3.6 meters. So we will not be checking the units anymore kasi nagawa na natin yan kanina, no? We know that everything is in meters. So now we can calculate for the value of E2. Starting with this first part here. So we have 0.943 squared divided by 2, then divided by 9.81. So this is equal to 0.053, 453 I mean. Tama ba? 0.0453, okay? Meters. So our unit is in meters. Plus, now we will calculate for this part ng ating equation. So we have 60 times 1000. So that's our numerator, no? Divided by 0.877 divided by 1000, then divided by 9.81. Okay, so we have 6.974. So we have here 6.974 meters, then plus 3.6 meters. So therefore our E2 is equal to 6.974 plus 3.6 plus itong value dito 0.0453. So therefore our E2 is equal to 10.62 meters. Okay, so 10.62 meters. Okay, so ano yung ating head loss? Sabi natin kanina, our head loss is equal to yung pumasok sa ating section 1 na energy. Energy 1 minus yung energy na lumabas. So we have energy 2. So yung difference nila, yun ang ating head loss. So our head loss is equal to our E1, which is 14.13 meters. So we have 14.13 meters minus our E2, which is 10.62 meters. So therefore, our head loss is equal to, okay, we have 14.13 minus 10.62 is equal to 3.51, okay? So we have 3.51 meters. So yan ang ating head loss. So this is our final answer here. However, meron pa tayong isang question na dapat sagutan. Tinatanong dito is yung direction of the flow. So paano natin makukuha kung ano yung direction ng flow? So remember, we have energy coming in and we have energy coming out. So we have E1 and E2. So ano yung mas mataas na value sa atin? As you can see, our E1 is equal to 14.13 meters and our E2 is equal to 10.62 meters. So nakikita natin that our E1 is greater than E2. So therefore, mas malaki yung energy ng ating E1 kaysa sa E2. So therefore, alright, so our direction of flow is from section 1 going to section 2. Okay, so makikita natin yan base sa value ng ating energy sa inlet and the value of our energy sa outlet. So since mas mataas ang energy ng ating inlet kaysa sa outlet, that means our fluid is flowing from our point 1 or section 1 going to section 2. Okay, so that is all for now and I will see you in our next lecture.